want to know if this number 335 can be written as the sum of three square integers. And just to be clear, 0 is a square integer. It's equal to 0 squared. Okay, and also 1 is equal to 1 squared. So let's keep in mind those trivial ones as we move along. Now, so again, here's one where it comes fairly close right here. 15 squared plus 10 squared plus 3 squares. You guys can do the computation. It's 334. It's very close, right? Close but no cigar. It's close. 334. It is the 334 is the sum of 3 squares, but it's not equal to 335. So that's kind of what we're looking at here. Do these type of numbers exist where 3 squares will sum to 335? Now, something that it'll be hard for me to motivate is the importance of modulo 8 arithmetic right here. Now, y'all, when you divide a number by 8, you're guaranteed to get a remainder of 0, 1, 2, 3, 4, 5, 6, 7 by the division algorithm. Okay, so what we're going to do is just look at those numbers, 0 through 7, and go through the arithmetic here. Well, 0 squared is 0, 1 squared is 1, 2 squared is 4. Now, 3 squared is 9 because 9 minus 1 is 8. 4 squared is equal to 16, which is a multiple of 8. And let's not forget that 8 is congruent to 0. And I'm bad about not writing it down, but sometimes you'll see it written this way, mod 8. They'll abbreviate modulus. Okay. So anyway, all these computations are fairly easy. 49 minus 1 is 48, which is a multiple of 8. 36, when you divide it by 8, leaves a remainder of 4. Okay, so that's why modular arithmetic is sometimes called remainder arithmetic. All right, now, so what we've concluded here is it's kind of nice. Any square integer, there's only 3 possibilities, 0, 1, or 4. And you can see those are the possibilities here. 1 here, 4. We have 4 here also. But 0, there's 8 possible remainders, 0 through 7. But the only possible remainders for a square are 0, 1, and 4. And that limits things quite a bit. So the rest of this is just going through the possibilities here. And I have x squared plus y squared plus z squared. And these are just all the possibilities. Notice 0, 1, and 4. And I'm just trying to sprinkle or distribute these 1 and 4s and 0s all over the place. And you'll notice that one thing pretty nice. And y'all, 4 plus 4 is 8, congruent to 0. So this is 4 here. But notice that what we can conclude here, and again, perhaps this is far from rigorous, but notice that 7 never came up here. 7 was never a remainder or a result of the modular arithmetic here. Okay, so what we can say is this. We can say that for any x, y, and z, you can pick them randomly if you want. There's no way that can ever be congruent, and I'm going to write this congruent with the slash. It can never be congruent to 7. Okay, y'all. Again, we went through all the possibilities here based on this lemma. The only remainders are 0, 1, and 4. And when you add up all these squares, all these combinations, and I may have left some out, but 7 does not happen, folks. 7 does not happen. So what that's saying is any number that leaves a remainder of 7 cannot be written as the sum of 3 squares. Okay, so let's take a look here at our number of interest here. 335 is equal to 8 times 41 plus 7, you guessed it. But another way of writing this, folks, is to say that 335 is congruent. 335 is congruent to 7. It leaves a remainder, mod 8. Okay? So, y'all, what does that mean? It means it cannot be written. So, this cannot be written. I'll just write up here, I'll just say not possible for it to sum to 3 squares, even allowing for 0 and 1. To sum and I'll just point up here, folks, just to cut down on the time. Okay, it's not possible to sum 335 as 3 squares. All right, again, notice we didn't have any remainders of 7 going on here. But 335 is demonstrably congruent to 7 mod 8, right? This statement right here, 8 times 41, what is that? 828 plus 7 or 328 plus 7 is 335, right? This remainder here is what's killing 335's chances of being written as the sum of 3 squares. And again, notice we got kind of close up here, but it didn't. It was close. It was close. But all of this work right here proves that 335 or any other number that's congruent to 7 modulo 8 cannot be written as the sum of 3 squares. Thanks for viewing.